See the baby in the mirror? That's a good sign. Okay, Karen. Karen, today we're going to learn about geometric series. Would you want to learn about a geometric series? Sure, I do. Okay, let's try this geometric series. As I was going to St. Ives, I met a man with 7 wives. Each wife had 7 sacks. Each sack had 7 cats. Each cat had 7 kits. Kits, cats, sacks, and wives. How many were going to St. Ives? Well, that's a very interesting riddle. And today we're going to work on the answer to that riddle. And Kieran is going to help us. Aren't you? Good boy. Okay, Kieran. What we're going to do now is we're going to move over to the whiteboard. And what we're going to do is we're going to solve that riddle. Now, you might have heard that one answer to that riddle is just one. That there's just one person going to St. Ives. But that's kind of like a cop-out. Okay, we're not going to do it like that. We're going to assume that when we went to St. Ives, that we met someone else going to St. Ives with us. We were all going together. Okay? So, now, let's just write down some of the important things about that. We met a man with 7 wives. Okay, he had 7 wives. Each wife had 7 sacks. Each sack had 7 cats. Each cat had 7 kits. Okay, and then of course there was the man, and then there was myself, because I was going to say that. So we can throw them in at the end. They're not going to be so critical. Now, the reason why this is a geometric series is, a geometric series is a series when you have a number of a sequence of numbers, and each number is related to the number before it by a certain factor. That factor is called the ratio of the series. In this case, that factor is 7. Okay, 7. So, and the series that we're going to be interested in is 7 wives. That's the first one in the series. The second one in the series is going to be the number of sacks. That's 7 times 7. And then we're interested in the number of cats. That's going to be 7 times 7 times 7. Wow. And then we're interested in the number of kits. That's going to be 7 times 7 times 7 times 7. And this series has only got 4 terms in it. But the ratio between each of the terms is relatively high. 7. That's relatively high. And in a general form, we'd call this P0. That's the first term in the series. That's the first term, right? Oh, okay. Why don't you come over here? There you go. That's it. You want to see? Of course, you want to see what's on the whiteboard. Actually, I apologize. Now, the second term in the series would be P0 times R. R in this case is going to be 7. P0 is also 7, which happens to start at 7. Third term in the series is P0 times R squared. And the fourth term in the series is P0 times R cubed. Those are the terms in the series. Now, in this particular problem, what we're going to try to figure out is the sum of all of those terms in the series. And then at the end, if we don't forget, we're going to add in 2 more, one for the man and one for the narrator. That's not so critical. What we're really interested in here is the geometric series. But now, there are a couple of ways to add a geometric series. Most of them involve, well, we could actually just multiply all this out with a calculator and add them all up. We could do that. Or we could do it longhand on a whiteboard. But we're going to get a little formula because later on we're going to want to do a geometric series that's much larger than 4 terms. Okay, so what we're going to do is write sum equals P0 plus P0 times R plus dot 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 P0 R to the n minus 1. And I put in the n minus 1 because now the total number of terms is n. So in this case, there are 4 terms down here. But n, the last is r to the 3. So if I put an n for 4 terms, that's going to be r to the 3. That's just the convention that we use in this class on that. It's not that critical, but you have to make sure you get it right. Now, there's a little trick to doing this sum. The way to do it is you multiply the sum by the ratio r to get that sum is equal to P0 times r plus P0 r squared plus dot 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 P0 r to the n. And then if you subtract the first one from the second one, you'll see that you can actually then solve that for what the sum is, because most of those terms just cancel right out. And even if it's very, very long, most of the terms will cancel out except 2. It's the one on the 2 ends. And that's a little bit like what Gauss did on the arithmetic series. It's a little bit of a trick, but it's different because you have to multiply it. So what you get here is you get r times the sum minus the sum on this side. That's this minus that. And then on the other side, you get P0 r to the n minus, and then the other term that's left over is P0. So the sum times r minus 1 is equal to P0 times r to the n minus 1. And then that gives you that the sum is equal to P0 r to the n minus 1 divided by r minus 1. And that's the formula in our book. And in this case, just to go over that again, the P0 is going to be 7, the r is going to be 7, the n is at 4. N is the number of terms in the series. That's something you have to always go back at. So now we can find out how many we're going to say in ives. Just by plugging in our numbers. So let's get rid of everything here except for the answer. Okay, and we'll find that the kits, cats, socks, and wives, that is of those, just those, that sum is equal to 7 times 7 to the 4th minus 1 divided by 6. That's equal to 7 times 7 to the 4th is 49 times 49 minus 1 over 6. Now I'm just going to use my calculator to get 49 times 49. It's 2,401. So I just subtract the 1, I divide by 6. And that's 2,400 divided by 6, that's 400. Times 7, that's 2,800. So this is equal to 2,800. That's the number of kits, cats, sacks, and wives going to St. Ives. There's only 4 terms, so you could have added it up on your calculator anyway, but this problem could have gone up to 100 terms. We still would have got this just with a relatively simple calculation on a calculator. Now, if you want to throw in the other 2 people, you could say sum plus 2 is equal to 2,802. I think the nice thing about this riddle is it actually has more than one different answer. Just depends on how you interpret it. This is the big result. We're going to use this for a lot of other problems. It's the summation of the geometric series. So Kieran, you've been very, very good. I'm glad you enjoyed this.